Hi, welcome to Fun at Pi videos. This is DC here. In this video, I'm going to discuss about sector trailer access bits using Mifare Classic EV1. This concept will also apply for the older generation of the card that are referred to as Mifare Classic cards. So you have to first know the contents of the sector trailer. Now in my previous videos, I mentioned about the various blocks you can see in the Mifare Classic cards. You got the blocks where the data is stored, as well as a separate block where the access rights and the keys are stored, and that block is called as a sector trailer, and the remaining blocks are for storing the user data. So a sector trailer consists of 4 things. It has got 6 bytes to store the value of key A, that's from the byte number 0 to byte number 5, followed by 3 bytes of access rights. So these access bits are used to configure the read and write of all this block in the sector, followed by 1 byte of user data, and this byte you can put any data you want, and this is nothing to do with the access rights at all. And this is followed by 6 bytes to store the value of key B, that is from the byte 10 to byte 15. So there are 4 different things in the sector trailer block, and what you'll end up doing is, say for example, take the value of key A. So you're going to mention, or you're going to set whether the key A is changeable or not, and if it is changeable, whether you need to authenticate using a key A or key B, or you can also change the access rights so that the key A cannot change at all. It's a frozen. So likewise, you can also decide whether the value of key B is changeable or not, and if it is changeable, whether you need to authenticate using key A or key B, or the key B is completely frozen, so which is not changeable. As well as for the access bits, you can specify whether it's changeable or not changeable, or if it's changeable, whether you have to use authentication with the key A or key B. The one thing you have to keep in mind, in case of the Mifare Classic tags, you cannot read or write any block without first authentication. Now this is nothing to do with what you're going to learn in this video. However, I thought this is the best time to address this a concept as well. So I've been asked many times whether it's possible to clone the Mifare Classic tags. So the best answer is I don't know. So I don't think you can do anything like this using a software, but if you go to internet and search, you will come across something. These things are possible using the hardware, but I don't know how they do it. Probably you need some kind of a electronic device that will look into the semiconductor level. So obviously these type of questions worries the software developers as well, because end of the day we create a software so that the customer can trust and they can make sure the software solution is secure. Now in internet there are many articles that speaks about the Mifare Classic hackable thing. Probably can get more information there, but from the software developers point of view, so this looks like feasible. So it is feasible in a way that we know the value of the key is 48 bits. So if you get the number of the decimal equal to 48 bits, it's something of this number. So you might think as a developer you can keep authenticating from the value of the key with 0 and go up to the number of the key which is shown here. And if you apply how many comparisons you can do in a day, in a year, okay, and probably you'll come across this will take probably millions of years. So there is a way to make secure. So it is possible to have a very secure card using Mifare Classic EV1. So I would always refer to EV1 because I don't think you can buy any more Mifare Classic, the earlier version of the card. So if you're doing any new project, please go with the Mifare Classic EV1. It has got some kind of a security feature inbuilt. The problem what we can do is you can try to create a secure solution, a software solution. So some of the way you can do is not to use the same keys for all the cards. So if you got a software system that uses say 100,000 cards, so better not to give the same key value for both A and B, because if you think the software key is hackable using these methods, you are going to compromise the entire system. So instead of that, every card can be given a unique or its own key, and that's called the key diversification. So this is what the solution used by probably most of the software developers. So probably you'll have you got a master key which is diversified based on the value of the UID or some other properties of the card. So some other solution which you can use is to encrypt the data stored in the card itself. Again, the encryption is done using a different key, not using key or key B, but different key. Again, that is diversified as well. So there is a way to build a system that's secure using this Mifare Classic EV1 tags. Or if you want the security built into the card itself, probably now you can go with the secure tags like Mifare, Desvar, EV1 or EV2. So this is what you're going to learn in this video. You're going to understand the various access rights of the sector trailer, and I'm also going to discuss some of the pros and cons of each of the configuration. And this is the table you get from the Mifare Classic documentation, and we are going to discuss every entry of this table and say where this configuration is best suited. So throughout this video series I'll be using this software called A722 Made Easy, and this is the version 2.0. So if you don't have this software, you're still going to learn all the concepts you have to know about the sector trailer. So we have made a lot of changes to this Mifare Classic 1K screen. So I'm just going to quickly go through so that now. So I have kept a Mifare Classic key fob. I'm going to activate, and I'm going to read the entire tag using the factory keys. All new tags come with the key value A and B set to FFs. And also, if you look at, since this video is about the sector trailer, the access rights of sector trailer is also set to 1 for all the blocks. sorry, for all the sectors. And so I already got some lorem ipsum stored in the entire tag. Now I want to show you a couple of few things that are added in the software. You can now transfer this entire grid content to the tag. So I'm going to just set the value. You got so many features here. If you right click, you can, there's a pop-up here with the format value block, change access rights, autofill. I'm going to use autofill and set this to 0. I'm going to do that for the entire card. So here, this is what you see when you buy a brand new card. So all the data blocks are set to 0, 0, with access bit set to 1 for sector trailer and 0 for the data block. Now I'm going to transfer everything. I'm going to write it to this brand new tag. I can see that what's happening within the software is just looping through. So all these blocks, there are 64 blocks altogether, and write each block using the standard PCSC update binary command. Now if you go to this tab called access bits, so here you can use this the playground tab to play with the values of the access bits. And I made a video on this. Please, I would advise you to see that video. And here, this is the content of the table, which you can reference here. Now, in order to change the access rights, you have to first click on the sector trailer block, because if you click elsewhere and if you right click, the access rights, change access rights pop-up menu is disabled. If you click on, all the sector trailer blocks have been highlighted with the gray background. If you right click and choose this change access rights, and you get this pop-up menu, and this is where I'm going to discuss all this sector trailer concept. So you can choose whatever value you want, and this pop-up, you can also choose what access rights you want for various data block, as well as the access rights for sector trailer, and say OK. Now this modifies the 3 bytes where the access bits are stored. That's B6, B7, B8. It's this A5, AB, and 45. And if you remember, I mentioned about the byte B9. This is like a user memory. You can type whatever you want. Some software they use this to store some data as well. So all the changes we have done so far, it's still in the software. In order to transfer this to the card, you have to choose the W, the write command. So which I'm going to use in the rest of my videos. So this is the table you have to understand and master. There are some pattern in this table. The first pattern is, if you look at the key A section here, so for each section it says whether you can read or write, read or write, read or write, and the left side is the values of the access rights. You can go up from, you got 8 combinations here from 00 to 111. You can see here for key A, it is not possible to read the value of the key at all. Now whatever is the configuration here, you just cannot read the value of key A. This is one pattern. So likewise, you can, if you look at the right section, you got some scenarios here where the key A is not writable at all. Say for example, you cannot write, in the sense, write means change the value of the key A. So this one entry here that says you cannot change the value of key A. There's one more here, one more here, and one more here. So there are, out of 8, 4 combinations of the access rights will never let you modify the value of key A. So there are 4 combinations where the key A is modifiable. So again, so the way you understand this this entire column is, now we know that when when you set to never, you cannot modify the key A. What about this one? Now this says you can modify the value of key A only after this block is authenticated with the key A. So here, if the sector trial access rights is 4, you can modify the value of a key A, but you have to first authenticate using key B. So likewise, here also it's the same thing. If you look at this access rights, look at the readability of access rights. So access rights is always readable in one way or the other. So for example, here you can read, but you have to authenticate with the key A. So there are some combinations where you can read with either key A or key B authentication. That's what you see here. So there are almost 5 entries, okay, where the access key is so access bits, the 3 bytes are readable, whether or not if it can be A or B. So likewise, you can set, if you look at that, there are entries where you can prevent changes to access bits. So if the access bits is not changeable, you cannot configure or change the read or write ability of any of these blocks. So there are almost 5 entries here that can make access rights not changeable, and only 3 entries here. So in order to change in this entry, in order to change the access bytes, you have to authenticate using key A. Likewise, these 2 entries says that in order to modify the access bits, see here we are speaking about the 3 bytes that are dedicated for access rights. So you can modify if you authenticate with key B, and key B is here, okay. So likewise, if you look at the key B, so there are some scenarios where you can make a key B not readable at all, but key B is also readable in some configuration here, like for 0, 0, 1, 0, that's 2 and 1, the key B is readable. Wherever this key B is readable, you'll come across a small superscript here. So if you look at the documentation, what you find there is, wherever the value of key B is readable, you cannot use key B for authentication. So it's a very good feature to have, because I've seen some of the software system use to store the user data in place of key B. So this is part of the software system design. So if you look at the last column, so this refers to the changeability of a key B. There are around 4 scenarios where key B is not changeable, and 4 scenarios where they are changeable. But in order to change, you have to first authenticate using the key that's mentioned in this table. So this is just a background. Next I'm going to show you, we'll go through one at a time, and we are going to see that by setting this we are not able to do certain things what the table says. So this time I'm going to use a brand new Mifare Classic EV1, which is already set to 4 byte UID. So I'm going to activate. You can see this has got 4 bytes in UID. You can also buy Mifare Classic EV1 that has got 7 bytes UID. So I'm going to read this entire tag. Now first we are going to see, so this table here, this is the sector trailer access rights. Now every brand new tag comes with the access bit set to 1 for the sector trailer. Now you know that when it is 1, you can change the value of key A. I can change the access bits, and also I can change the value of key B. But however, what the software does is, it is showing the value of the key A here in the grid, because this is just a software feature, but when you try to read, I'm going to show that if you hit this R button here, this reads. So before that, if you try to read, you get the read is failed, because in order, before you read, you have to first authenticate. I'm going to authenticate sector 0 using the default key FFFs. Now if I go and hit this R button, you can see that this is the data you get from the card. The first 6 bytes is the value of the key A, which you'll always get as 000, because key A is not at all readable. Doesn't matter which configuration number you got, they're not readable. So this is followed by the 3 bytes for access rights, followed by the user data, followed by the value of key B. Now now we have got the system where the sector 0 is authenticated with key A. I'm going to change the value of the key A. You can either use change A, but I'm going to edit. I'm going to give some value for key A, A0, so A1, A2, A3, A4, A5. So I'm not going to touch this access rights bits. Probably now I can also modify this set to 00. Then comes the value of key B. I'm going to set this as a B0, B1, B2, B3, B4, B5. So I'm going to change the value of key A and key B. If you hit this W, so it says write is successful. Now the write is successful. If you try to read, see, when you try to read, we get a error message. So it is because as soon as the value of the keys are changed, you have to re-authenticate. We just modified the key from default FFF0 FFF to A0, A1, A5. So what I'm going to do is I'm going to first authenticate, but this time using the key we just modified. Say authenticate. Now I'm going to read. If you look at here, again the value of key A is not readable. The card returns just all bytes as 000, and I got the value of key B. I got the modified key value. Now, is it possible? I'm going to try something what the documentation says. I'm going to authenticate this card using key B. B5. If I authenticate, you get authentication success. If you look at the various commands that are used, these are the standard ACR122U commands. You have to first load the keys, then you're going to authenticate, this time using the value of key B, that's 61 is the key B. Now the authentication is successful. However, if you try to read, I'm going to read the entire sector here, or you can just hit this block read. You can see that the read fails. This is exactly what the documentation says. So it says when it is if you look at here, probably I got somewhere in the software. So here what it says is there is a star here, 1, probably the software doesn't show. So it says key is readable, may not be used for data. Okay, may be used for data, that's what it says. Sorry, go back to this the entry for 001. It says key B may be read, and this a superscript 1 here. On the bottom you will see that key B cannot be used to authenticate because it's readable. So it makes sense, because you don't want the authenticate key to be readable.